Grind 75, week 4, problem 2, implement the trie. Prefix tree. A trie, pronounced as trie or prefix tree, is a tree data structure used to efficiently store and retrieve keys in a data set of strings. I remember working with tries back in my college days. We had to play around with those as a data structures course or something like that. There are various applications of this data structure, such as autocomplete or spell checker. Yep. Implement the trie class. Trie initializes the trie object. Void insert string word inserts the string word into the trie. Boolean search returns true if the string word is in the trie, i.e. was inserted before, and false otherwise. And then we have a starts with. Okay, and so they give us a little struct. They warn us that we have to make self-mutable for some of these guys. That's fine. Your trie object will be instantiated and called as such. Let obj equals trie new, object insert word. Ret2 bool is obj search word. Let 3 bool equals obj starts with prefix. And then we have test case here. One test case. That's all we should need, right? Insert search search starts with insert search. What? Oh, okay. So this is just. Oh, okay. I think I see. So this is instantiate a trie, not expecting any output, or no arguments, not expecting any output. Insert apple, not expecting any output. Search apple, return value should be true. Okay, so this is not output, this is return value. Search app, return value is false. Starts with app, return value is true. Insert app, no return value expected, and then search for app, return value is expected to be true. Okay, and we can actually just grab this code. I have to change this first line, but everything else stays the same. This looks like Java, right? All right, let's go back to our lib. Oh, let's commit this change first. See if Clippy's okay with it. Nope, let's fix that up. Nvim 207. Oh, right. Lib 207. Come on. I said jump to definition, and it's not jumping to the definition. Okay. Oh, there it goes. It was just slow. Line 13, we can clean this up better. It says try this or default. How would it know what the default thing is? I mean, let's give it a shot. Right? It would have to know based on this what the default is. Right? Is it going to say not able to understand what the default type is? Yeah, type must be known at this point. So I'd actually have to define the type here. So hash map of view size, hash set of, what was it? U size? Colon. I forget the colon. There we go. Yeah, okay. So I have to specify the type here, but it allows me to use or default. All right. And the test, run doesn't work. Test should all pass. One thing that would be nice for Bacon to say is, don't print out any OK tests. Ignore those. If everything passed, just give me this one line. That's all I care about. All right. Git status, git add. Oh, let's take a look at what I've been using for log. So problem number, and then the description. Okay, git status, git add source, git commit -m problem 207 course schedule. There. All right. So now we're going to do this try. Let's copy all of that, and now it's problem number 208. Got consecutive problems this time around. 02, 08. implement try. Paste. This is not going to build because these don't return anything. False, false. So let's just get this to build. Expected item after doc comment. All right, let's not make it a doc comment then. Expected struct try found unit. Oh, okay. You just say self. There, okay. Yeah, we have a bunch of warnings because we're not using stuff. All right, so how do we do this? So we have we can do a sort of a tree-like structure, I guess, which is not all that easy to do in Rust, but we can do it with, say, a box or an existing vec. Maybe that's cheating, but maybe that might be the easiest way to do it. Here's what I'm thinking. So we have a try list, which is going to be vec of self. Does that work? Or do I have to put try in there? And then children, which is going to be a hash map, which means we need to pull a hash map in, from char to usize. So this is going to map character to an index in try list. And then, is that all we need? And then we can just derive default. And this will just be self default. And then this doesn't exist, so let's import it. Okay. So insert then has to take a mutable reference, and it needs to do, it's got to iterate on the string and work its way. Oh, I guess what we could do is do it recursively. What we could do here is, for example, we could say actually, wait, hang on a sec. So we can do fn. Oh, you know why these are all this? Oh, I know why. Okay. Yes, it's because all these need to be pub in order to build. I think that'll clean up some of the warnings. Nope. I was wrong. Oh, yeah, so these warnings. Oh. Is that going to be like that forever? Because it's an associated function instead of a... Yeah, and even if after I write a test, and I can just, oh, this is test like this, ex1, and what we can do is just copy paste all this Java code and then convert it into Rust. And then change all of these things. Oh, this needs to be let mut new. And then all of these return trues. Oh, into. All these need to be intoed. And then we can change all of these guys where it says return true, return false. We can just turn those into asserts, right? Assert, bang. Assert, bang, bang. Assert, bang. And assert, bang. Like that. Right? And now if I save that, what happens with the tests? Oh, starts with, yeah. Okay. Right, and then we're not using these guys, and it's going to still complain about the new not being used. This actually, none of these should complain here because this is all library. Oh, there it is. Right. Okay. There we go. Now we're only complaining about the function parameters and not the functions themselves. Good. Okay. That's what I was missing. All right. So to insert, let's create a helper function, char insert, which takes a mutable reference to a self and an iterator on chars, right? I think it's called chars. H equals word dot chars. Yeah, so it's just capital C chars. So we can take that. And what this will do is it'll walk through each entry in the iterator, and then that'll allow us to walk through this tree. So we'll look up which child it is in here. And then we reference it here. We're using this as the index into the trie list. And then we recursively do the next character. It's probably not the ideal solution, but hopefully it will run quickly enough that they won't complain about excessive runtime. So iter next. Right? So this should be a char. It's saying unknown. Why? So I should actually be able to say self char insert word.chars. Right? Println. Oh, chars doesn't exist. Okay, let's import that. And insert is misspelled. Cannot borrow is mutable. Now I can. All right, there we go. And we see the letter A, and then it exited. Okay, so this is working. Very good. Now we want to do is look at our children's hash map and see if that entry exists. And if not, we have to add it to the trie list and then insert a new value here. Is that a job for the entry API? Let E equals self children entry of ch, and that's an entry of char usize. Oh, we have to, if it's or insert. Oh, we can't just do it this way. There's an insert with, right? Let me find out. I have a hash map here. Ugh. What happened to this? There we go. I had to hit refresh to get that. So entry gives us an entry, and we can do or insert with, and that gives us a function, right? Because we need to do we need to insert a brand new entry into the trie. So we say let num is equal to self trie list len, self trie list push, try new, and then we're going to say, what do? We have E. We just grab the number that we want to insert. Yeah, do we just return that? And then here we could say E right, and now we need to do it recursively. So the E actually gives us, yeah, the use size now. So what we need to do now is say self try list of e dot char insert iter. Right, and if iter next returns null, then we're done. So else, is there an else? There's no else. Right? Let's do that one insert and then we can print out what everything looks like. So println, we'll do this and then self try list and then println, same thing, self children. Actually, I can derive a debug from this, right? And just print it. Right? I messed up. What did I mess up? Oh, I forgot to close the F. I misspelled that. All right, what does this look like? Blah, 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 blah. So we have A, P, P, L, E. And this makes sense, right? Do all these zeros make sense? I think they do. It's saying that P maps to the 0th entry in the trie array. I think this is it. It's kind of awkward, but this is doing the trick. Okay. So now, insert should work. But now we need to implement search. How do we do search? Because that's the next thing to get to work is this line here. We want to walk our way through the word. And I guess we can do something similar here, a little helpful function, char search. This does not have to be mutable, but we do need a mutable reference to the char's iterator. And this is going to return a bool if we found it. So this starts off the same way. If let sum ch is equal to iter next. If we didn't, then false. Right? If we got to the end and we ran out of letters. I've forgotten something here. Right? Because we have a starts with. We want to be able to reach the end and then return true for starts with. We also want to be able to return true if if we have a full word, right? We want to get to the end and then say, was that a word? Okay. I think what we can do is we could just wow, that's so annoying. I'll just put it out here. Word bool. There. Okay. So this we'll set this to true if we ran out of letters. So that would be under the char insert. We ran out of letters, then our current try is a word. Self word is true. And then we need to know here if we're searching for a full word or if we're searching for a partial match. So if full and self word true, else then we found a partial. I was going to say else true, but that doesn't make sense because else if not full, then it's okay. I'm going to clean this up in a second. Else false. All right, so obviously here what we can do is we can return not full. There we go. Right? Right. And now we don't have a search thing for here. So this is where we're going to go recursively again. We can use the same logic that we have up here, like let e equals self children entry ch. Oh, and now if it's, oh, so we can do let, we can actually say get, right? Because we're not modifying it. We can say if let some try is this, and this should be, it's a usize. If it exists, then we'll keep searching. So self try list try. Oh, was that an ampersand? It was. Dot char search iter. Else, if we couldn't find it, then we just return false, saying it's not there. And then here, we say self char search, and word chars, and we're looking for the full. And this got a bunch of underlines here. What's going on? Oh, this probably is that, right? This has underlines here, and I'm not sure what that means. Oh, argument type bool is missing. Full. Oops. There's a path which has, oh, there. Okay. So example 1 is still failing, but where? Is it failing in a different location? Line 72. Okay, so we were able to get this to pass, but we don't have the starts with working. Let's get rid of the insert thing here. Oh, the starts with doesn't work because it's just a self char search. Word chars, false. Oh, prefix. Okay. All right, we have that working now. Mr. Dick Steele, hello. Thanks for joining. Mr. Dick Steele asks, hey, what do you have running on the left window to show errors on compilation? This is called Bacon. It's just a command line utility called Bacon. It's available on GitHub, or you can say cargo install Bacon, I think. Yeah, cargo. It's even in my history, and it's a cute little program because what it allows you to do is it allows you to, with a single letter in this window, just run any one of these things. Like I can hit run. It's not going to work because I'm building a library, not a binary. I can hit T and it runs all the tests. And then whenever it sees the file change here, it'll automatically rerun. Yeah, git Bacon. I've looked at this here. It is canop. So if you want to take a look at the source, I will throw that in chat and you can take a look. But it's really handy for like my Advent of Code thing where you could just do all the stuff. You can also run Clippy on it and it'll tell you Clippy errors. Oh, okay. Yeah, we can clean that up. But let's see if this is the right answer first before I start cleaning things up. Let's go over here to implement try. All right. Grab all these lines. Oops. Let's go this far. Paste. And then we'll take it from char search down. Paste. Submit. Oh no! Oh, did I? Oh, I messed something up over here. Oops. Can I hit undo? I can. Good. Somehow I accidentally pasted that word in there. Oops. Closure construction occurs. Whoa. That doesn't happen here. I wonder if they're running an older version of Rust. Oh, 158.1. Yeah, and I'm not running 158.1, am I? Rust C version. What, am I? Yeah, 166.1. So this must be a problem that is not a real bug. First borrow used later by call. Borrow happens here. Second borrow used help. Second. All right, so we have to rewrite this then in order to support the older version of Rust C. How do we do that? Let's do this first. So we have reference for the code. Let me also clean up the Clippy problem since we're making changes. And yeah, it's just this. Okay. Right, and now Clippy should be happy. Right, okay, so now what we need to do is say match self children entries. CH. And I think if I do this, I can do a quick fix. Oh, it won't let me do that. Oh, maybe I can do it this way. I thought this would allow fill match arms. There we go. Okay, so now we have entry occupied and entry vacant. So let's delete those things. And now if it's occupied, all we need to do is say self. Oh, we have to give this a value here. And this one has to have a value as well. Oops. There. So if it's occupied, we go self try list of O dot something. O dot something. I just had it. Here it is. Entry occupied gives you an occupied entry, and oh, you can just call get on it, and that returns a reference to V. A reference to V, which means we have to deref it. Get char insert iter. If it's vacant, that means we have to do this business. And then we got to insert it into the vacant entry. And I think it's just insert on vacant, right? Yeah, insert value. Perfect. So it's v.insert num. And then we still do self try list num char insert iter. And that replaces this line here. And I keep mistyping insert. Maybe I should have just called it that. All right. So, oh yeah, and then we need to import hash maps entry. All right. And now that changes our, okay. Let's go back here. Let's see if that does the trick. Now that we split it out, it should be happier, right? And then here, we're going to change this code. Oh, and this line as well. To this match. Right? Okay, let's see if that works. Does this build? Okay, so that it's accepted that. It's not the greatest. It runs fast, but it uses more memory than most. Okay. It would be nice to actually have this work, the or insert with work, but I guess the older version of the compiler couldn't deal with the fact that we were borrowing this immutably here and then borrowing it mutably. And then this is a borrow on a mutable thing as well. But anyway, we got that working by splitting it out into two separate steps, which is fine. I'm not going to complain. The tests still all pass, which I should have checked before. And Clippy is happy. Oops. So I think that's going to do it. Git status, git add source, git commit -m problem 208, was it? Oh, Mr. Dick Seal says, what was this speed difference to others? So it beats 60%. I can click on, I'm here. This problem with the speed difference is it varies so much. Like if I click on this one, is this going to be a similar solution? Oh, they're using, yeah, they're boxing it up. Okay, that makes sense. Yeah, so this is faster because we're not, I guess we're not recursing. This is just iterative, which is probably the right way to do it. Oh, that's interesting. Yeah, and then they're just assuming that everything's in lowercase. That was probably described in the problem, that it's all lowercase letters. Yeah, consists of only lowercase English letters. Okay, so that means you can do that to index into the trie box array. All right, I'm happy with my solution though. Implement trie. All right, we did 2. I think I have enough brain power left for 1 more.